Now that we have all learned how to take the derivative of some of the simpler functions, let's work on using the chain rule to solve compositions of functions. We will start with the function 2x plus 1 quantity squared. Without the chain rule, you have to multiply out and apply different calculus rules. Change it into f of x equals 4x squared plus 4x plus 1. It's basic algebra. And using the rules we already know, we get the answer of f prime of x equals 8x plus 4. Now that's great and didn't take much time, but what if the function is this one here? Here, the chain rule is necessary. We will come back to this problem later, but let's keep it simple and stick with y equals 2x plus 1 quantity squared. First, we let u equal 2x plus 1. Now our new equation is y equals u squared. And by the power rule, we are able to get a dy du equals 2u. Now let's take the derivative of u with respect to x. And now we get du dx equals 2. With algebra, we get dy dx equals dy du times du dx, leaving us with dy dx equals 2 times the quantity 2x plus 1 times 2, or 8x plus 4, the same answer we got without the chain rule. Here's a bit of a different example. Take the function y equals sine of 3x squared plus 5, and we're going to solve for dy dx. First, let u equal 3x squared plus 5. Now you have the equation y equals sine of u. dy du equals cosine u, and du dx equals 6x. Therefore, dy dx of sine of 3x squared plus 5 equals 6x cosine of 3x squared plus 5. Now that we have some experience with the chain rule, let's simplify by looking at it in symbols. All these equations can be looked at as y equals f of g of x. And by the chain rule, we can say that dy dx equals f prime of g of x times g prime of x. Now, we can use this easier way of looking at it, and we must also remember that the chain rule can be used multiple times. Take y equals 1 plus cosine squared of 7x and cube that whole quantity, and proceed with u substitution. First, let u equal 1 plus cosine squared of 7x, and then you get dy du equals 3u squared. Using the dy dx equals f prime of g of x times g prime of x rule, we get a du dx of 2 cosine 7x times d dx of cosine 7x. Set away the first part and work on d dx of cosine 7x. Cosine is the outside function, so we take the derivative of the outside function, keeping the inside function the same, to get negative sine 7x, and multiply that by the derivative of the inside, which is 7. This leaves us with negative 7 sine of 7x. Now we're going to pull the 2 cosine 7x back down, and once we multiply it, we get negative 14 cosine of 7x times sine of 7x. Now remember, this is just our du dx. Now we get a dy dx of multiplying our du dx by dy du. And we get 3 times the quantity of 1 plus cosine squared of 7x all squared times negative 14 cosine of 7x times sine of 7x. Now we can simplify it, and we are left with negative 42 times the quantity of 1 plus cosine squared 7x squared cosine of 7x times sine of 7x. This is a complicated example, but it's important to remember that the chain rule can be used multiple times in the same equation. But now we have mastered the chain rule. So let's go back to the function y equals 4x cubed plus 5x squared plus 3 quantity raised to the 4th power. We can see that the outside function is the 4th power. So the derivative of the outside function, keeping the inside function the same, is 4 times 4x cubed plus 5x squared plus 3 quantity cubed. And the derivative of the inside is 12x squared plus 10x. Now, once we multiply and simplify, we get a final answer of a very complicated function by using the chain rule. Without the chain rule, we would have had to multiply this function out and then use the power rule and the constant multiplier rule and use all those different rules that we've already learned to find this derivative. But we wouldn't have time to do that on the AP test. So therefore, the chain rule is something that helps us find the derivative of more complicated functions without wasting very much time. Thank you.